All right, so if you're a data scientist and you love using R, I bet you've run into this problem. You hit a wall. Your data set is just huge, way too big for your laptop to handle. So what do? How do you scale up your analysis without having to ditch the language you know and love?
Well, let's get right into the solution. As we've been saying, the final piece of the grid is the lab. This is it. This is the last piece of our Sentinel grid puzzle, that master blueprint for a complete data architecture we've been building. And look, when I say lab, I'm not talking about a room with beakers and test tubes. This is a high-performance analytics environment living entirely on Google Cloud. You should really think of it as a forge, a place where we hammer raw data into powerful, data-driven strategies, but at a scale you just can't imagine on a single machine.
So here's the game plan for this explainer. We're going to start with the why, the laboratory of alpha. Then we'll build our scalable R workbench, connect it up to BigQuery, and run some actual analysis at scale. After that, we'll talk about going from the lab to a real production environment, and finally, we'll see how it all fits together to complete the Sentinel grid.
So, what's our mission here in the laboratory of alpha? It's simple, but it's incredibly powerful. We're going to take the awesome statistical power of R and fuse it with the sheer raw scale of Google Cloud. The two main tools for the job, Vertex AI Workbench for our environment and BigQuery as our powerhouse data engine. Yep, this is that forge I was talking about. This is where strategy is born.
Okay, so, every great experiment, every great invention, it all starts with a solid workbench, right? For us, that foundation is going to be Vertex AI Workbench. This is where our analysis will really come to life. So let's dig in and see what makes this thing so special.
So what is Vertex AI Workbench exactly? The easiest way to think about it is as your own personal, supercharged data science environment that lives in the cloud. But the most important word there is managed. Because it's a managed service, you spend way less time fighting with infrastructure and all that setup nonsense, and more time actually doing what you love, uncovering those valuable insights from the data.
And you won't believe how easy it is to get started. I mean, it is literally a one-click deployment. You just pick the machine size you want, and, this is the crucial part, you can scale it up or down whenever you need to. Need more horsepower for a big job? Click, you've got it. Job's done, scale it back down. No more of that dreaded feeling of your laptop's fan screaming right before it crashes.
And the advantages here, they're huge. You get that on-demand scale we just talked about, you only pay for what you actually use, and it comes preloaded with R4.3 and all the key ML frameworks you need. But honestly, the deep native integration with services like BigQuery, that's the real game changer, and we're going to dive into that right now.
All right, this next part requires a little bit of a mental shift. It's a total paradigm change from how we usually work. Instead of trying to pull terabytes of data to our R session, which, is a recipe for disaster, we're going to flip the script. We're going to push our R computations out to where the data lives, which is inside BigQuery.
I mean, look at the difference here. The traditional way, you try to pull a massive data set onto your machine. Best case, you're waiting forever. Worst case, you get memory errors, and the whole thing just crashes. But with the GCP way, a query that would have taken hours or maybe wouldn't have even run at all can be executed by BigQuery across terabytes of data in just minutes. All we do is use R to send the query, let BigQuery do all the heavy lifting, and then we just pull back the much smaller, summarized results to analyze and visualize. It's all about efficiency and speed, and it's made super easy with the BigQuery package for R.
Okay, our lab is officially set up, it's connected to our data source. Now it's time for the fun part. Let's run an experiment. To really see this system in action, we're going to use a famously huge public data set, the New York City taxi trips data.
So let's take a peek at the actual SQL query we're going to send from R. It's pretty straightforward. We're just telling BigQuery, hey, go scan through millions and millions of taxi trips from 2022. I just need the fare amount, the trip distance, and the passenger count. Oh, and make sure you filter out any weird data where the fare is 0 or less. Then just send me back a manageable sample, let's say 10,000 rows, so I can start exploring.
And check this out. This is the R code to make it all happen. It's so simple, right? You just load up the BigQuery library, you put that SQL we just saw into a string, you run one function to execute the query against your project, and another to download the results right into a normal R data frame. It is that easy to tap into the massive power of BigQuery.
And this is the payoff. After all that, we're back in our comfort zone in R. We can use our favorite tools like ggplot2 to start creating beautiful, insightful charts from the results. So this simple bar chart right here, showing the average fare based on how many passengers were in the cab, this is a real, tangible result that came from analyzing a massive data set, and our machine didn't even break a sweat.
Okay, so running a one-off analysis like that is awesome. It's super valuable. But the real magic, the real long-term value, comes from making it a repeatable, automated system. So let's talk about the next logical step. How do we take what we just did in our lab and turn it into a professional, production-grade MLOps workflow?
And this forces us to ask a really important question. Your analysis works, great, but is it cost-effective? Is it reliable? Is it automated? See, a successful experiment is just the beginning. To really unlock its value, you have to be able to answer yes to all of those questions.
This is exactly where MLOps best practices come in. It's all about building a system that's robust and repeatable. You start your experiments with smaller, sampled data to keep costs down. You begin with smaller machine instances and only scale up when you really need to. And you're always monitoring your resource use, your costs, and your performance. Then, you can graduate to using tools like Vertex AI pipelines to completely automate your training, and the Vertex AI model registry to version and manage your models. This is how you make sure your insights are delivered consistently and reliably over time.
This table here, this is basically your roadmap. It lays out the whole ML workflow on Google Cloud. For every single step of the machine learning lifecycle, from data prep in BigQuery to model training to deployment, there's a dedicated managed service ready to go. You can see how they all fit together to create this seamless end-to-end production system.
And just like that, we've built the final component. The Analyst Lab is in place. It's not just a concept anymore. It's a powerful, production-ready piece of our complete data architecture.
The grid is complete. We've mapped the landscape, built the fortress, tapped into the stream, and now we've forged the lab. You have the complete blueprints now. You have what you need to go out and own the data-driven future. It all connects. It's all one cohesive, powerful system.
So let's boil it all down. What are the big things to remember? Number 1, R can absolutely scale. You just have to pair it with the right tools like Vertex AI and BigQuery. Number 2, the compute-to-data model. Always push your heavy processing to the data, not the other way around. 3, use an integrated platform. It makes the entire data science lifecycle so much smoother. And finally, number 4, always be thinking about that path from the lab to production. That's how you create real, lasting value.
This is TradingMaster AI. Build the future. Stay architected.
So there you have it. We've given you the complete architectural blueprint. Now the only question left is, what are you going to build? What incredible insights will you uncover in your Analyst Lab?